Hello there, and then welcome to a brand new video in this series of limits. Now in this video we'll be looking at how to look for the limits of rational functions. Limits of rational function, especially for those that they have no holes, that is, they are continuous at every point. We'll look at three methods to do that. So direct substitution, simplification, and then re-evaluating the limits after simplification. So without much ado, let's quickly go into that. But before I go into that, if this is your first time on this channel, this is Hub Beyond Numbers, where we try our best to learn maths the very easy way. Kindly subscribe if at the end of this video you find it helpful and then you need more of my videos to help in your studies. Let's quickly go into it. For this very first question, we want the limit of our rational function is what? X squared plus 3x plus 2 all over x plus 1, and we want the limit as x approaches -1. As x approaches -1. So to tackle this question, the first thing we need to do is to do our direct substitution. We first of all do what we call direct substitution. What that simply means is we look at the value of x where we want our limit and then substitute it there to see the value we are going to get. So let's quickly do that. Using the method of direct substitution, we are going to say that the limit of our function, which is x squared plus 3x plus 2 all over x plus 1 as x approaches -1 is going to be, so direct substitution simply means we are going to put the value of -1 in place of the x. You see, so wherever we have x, we put -1. So -1 for this first x, all squared. You see, then we have plus our 3 into bracket the x value, and our x value was also -1. That is from this side. Then plus 2 all over x plus 1. Our x value is -1, and then what? Plus 1. Evaluating this, you realize that this here gives us -1 squared, which is 1. Then 3 times -1 gives us -3 plus 2. All over -1 plus 1 gives us 0. This here is undefined, right? And we don't want that to happen. That simply means the direct substitution method is not going to work for this particular solution. So most of the times, if you have the polynomial function, just ask yourself, the x value you have been given, if you substitute it in the denominator, are you going to get 0? If you see that, you just not use the direct substitution. Then we go to our next method. So to be able to solve this, it simply means we have to simplify the functions. We would then have to simplify the function. So our function was given as x squared plus 3x plus 2 all over x plus 1. In simplifying it, we can factorize x squared plus 3x plus 2. And how do you factorize? As you can see, this over here is a quadratic function. So we have x squared plus 3x plus 2. Since it's a quadratic, how do we factorize? We have our 1 here. If you don't understand this section of this video, I would make another video explaining how to factorize quadratic functions. But if you do, I would try my best to go very fast so that we would have less time for this. So we have 1 times 2 giving us a 2. Then for 2, the factors of 2, that give us 3 are 2 and 1. Hence we have x squared plus 2x plus x, then plus r2. Factorizing this, we have x into bracket x plus 2, then x plus 2, we have a 1 over here, positive 1. So since there's x plus 2 and then x plus 2, we have x plus 2, then in under bracket x plus 1. I went fast because we are doing limits here and then I wouldn't want to go much into details, but all we are doing is, if you have quadratic and you want to factorize them, you are multiplying the value of the coefficient of x squared by that of the 2. If you multiply, we have our 2. Then if we have our 2, we ask ourselves, what are the factor pairs of 2 that when we add together will give us this over here? Factor pairs of 2, we definitely have 2 and then 1. And you realize that if you multiply 2 by 1, you are getting this 2 over here. If you add also, you are getting 3x. So instead of 3x this time around, we are going to write it as 2x. That is 2x plus 1x, which is x. And to factorize, most of the times you need even number of terms. So now that you have even number of terms, you consider this one and this together. And consider this and this also together. What does this x squared plus 2x have in common? They have x in common. Then into bracket, you write x times what gives you x squared, that is x. Then x times what value gives you 2x, that is 2x. And for this two, since they have nothing in common, we just write one outside and then put them in a bracket. Then at the end of the day, you realize you have x plus 2 and then x plus 2, giving you x plus 2 over here. Then you put x and then x plus 1 also in another bracket. For those who do not know how to factorize quadratic functions, if you need comprehensive videos on it, you can let me know at the comment section, because this is what we'll be applying in most of our examples, and you would really need to understand it before you can solve this type of questions. So it simply means for the numerator, upon simplification, we are getting x plus 2, then x plus 1. That is just for the numerator. Then we have all over x plus 1 and factorizing. So what we do now is we simplify. So simplifying, we know that these over here are multiplying each other. Hence, we can just cancel out this bracket and then this bracket. So at the end of the day, you realize that this whole fraction, this whole rational function we had over here has been simplified to give us what? X plus 2, simply. So it simply means if you want the limit of x squared plus 3x plus 2 all on x plus 1 at x, or as x approaches negative 1, then we should just look for the limit of this function over here, x plus 2, as x approaches negative 1. This now, as we did in our previous video, is just a simple polynomial. So we are just going to look for the value of this polynomial as x is equal to 1. So that implies we have negative 1 plus 2. We are substituting the value of negative 1 into x. And simplifying this gives us a 1. So it simply means that this whole function over here, its limit as x approaches negative 1 is actually 1. Right? And this is its solution. So I always do, let me show you the graphical representation of what we've done over here. So for this over here, we have the graphical representation of the function. Now, the blue line here represents this whole rational function as the x values increase and decrease. If we want the limit as x approaches negative 1, this is negative 1, this is its line. So let me take my ruler and then we try and then get its corresponding value. So I'm moving it so that it falls on the point of intersection. Now that it falls on the point of intersection, I'm going to draw a straight line. So as you can see, it is exactly on my point 1, just as we have solved. I hope it's understandable. Now let's go into another example. So in this second example here, we have a rational function being x squared minus 4 all over x minus 2. And we want its limit as x approaches negative 2. So using our first method, we know that the limit, our limit of x squared minus 4 all over x minus 2 as x approaches 2 is simply equal to we doing our direct substitution. just as we've been doing for the polynomials. So wherever we see x, we put 2 in place of that. So we have 2 then squared minus 4 all over another x value. So we have our x then minus 2. If you want to simplify this, we have 2 squared, which gives us what? 4. 4 minus 4 all over 2 minus 2. When we simplify, we have 0 over 0, right? So we have our 0 all over 0. Now, assuming the numerator was only 0, was just 0, and then the denominator gave us another value, we could say the answer is 0. But with this we have over here, as we can see, there is 0 as the denominator. And in mathematics, we do not want our denominators to be 0. It gives us undefined expression. So this simply means the substitution method has what? Failed. Our substitution method has failed. And we are not going to use that. Hence, we need to simplify our polynomial. So we need to simplify our rational function. So in simplifying, we have x squared minus 4 all over x minus 2. And this here is an illustration of difference of two squares. So you have x squared minus 2 squared all over x minus 2. And for difference of two squares, it says if you have a squared minus b squared, you should evaluate it as a minus b, and then b, and then a plus b. So this difference of two squares formula we have over here is what we are going to apply here. So looking at it, it simply means we are going to get x minus 2 and then x plus 2 all over x minus 2. Now we can clean this over here. Now what this means is we are going to cancel this bracket by this bracket. And at the end of the day, all this fraction we have here is just giving us x plus 2. So it implies that the limit we are solving for, that is the limit of x squared minus 4 over x minus 2, as x approaches 2, it's also equal to the limit of this function x plus 2 as x approaches 2. And what does that give us? From our polynomials, we said if we want the limit of these type of polynomials, we just substitute the value of x. So it means we are going to get a 2 plus 2, which is what? 4. This is, so this gives us what? 4 as the value of our limit. So as you have seen, we first of all did what? Did a direct substitution, and that didn't work. Hence, we needed to what? Simplify the rational function to be able to solve. So as I always do, let's quickly look at a graphical view of what we have here. So this over here is the function. This here is the function. And at x equals 2, we have this line over here. So we are looking at the point where they both intersect. Looking at the point where they both intersect, we are going to get what we call 4, just as we solve. So I'm drawing a line to illustrate that. This here is my line. I hope that makes sense. Yes. So you can solve it graphically as well, but you don't have the time to plot all these on your graph. So that is it. We'll look at our last example in this particular video, and then we'll continue something else in the next. So let's go to our last example. Now in this our last example here, it says we have to find the limit of x cubed minus 1 over x minus 1 as x approaches 1. So as we always do, let's use the method of direct substitution. So we are going to get the limit of x cubed minus 1 all over x minus 1 as x approaches 1. Using our direct substitution, wherever we see 1, wherever we see x, we put 1 in place of that. So we are going to get 1 cubed minus 1 all over x. We have 1 minus 1. Simplifying our numerator gives us 1 minus 1. 1 cubed gives us 1 all over 0. Now this here is a red flag because we have denominator being equal to 0. Hence, we don't use method of substitution. It simply means let's take our rational function and then simplify it further. So we have x cubed minus 1 all over x minus 1. The numerator here is what we call difference of two cubes. And let me write that here. For difference of two cubes, if you have x cubed minus, let me say 1 cube, it's simply equal to your x minus 1. Then you have x squared plus x plus 1. As I said, if you want videos explaining all these factorization terms, you can always let me know at the comment section. These ones are what would help you evaluate rational functions, because at the end of the day, if you can't simplify, it becomes very difficult, especially if your substitution isn't working just as we did over here. So substituting this difference of cubes in place of this, we are going to get what we call x minus 1. Then we have x squared plus x plus 1 all over x minus 1. And as we've done in the previous ones, this here we'll cancel this, so that at the end of the day, this whole rational function has been simplified to give us x squared plus x plus 1. We then do what? Do our simplification. So simplifying, well, we've done our simplification now. So it simply means that the limit we were looking for, that is the limit of x cubed minus 1 all over x minus 1 as x approaches 1, is simply the limit of x squared plus x plus 1 as x approaches 1. And this here has become a what? A polynomial. Hence, we do what? We do direct substitution once again. So instead of x, we are putting our 1. We have 1 squared in place of x squared plus 1 in place of x, then plus 1. And this here gives us what? 1 plus 1 plus 1, which is equal to 3. So it implies that the limit we're solving for, the limit of x cubed minus 1 all over x minus 1 as x approached 1, is equal to 3. And that is that. So looking at our graphical representation, this here was our polynomial. It was our rational function being graphed. And this is it points, the point we want the limit, this over here. So we just trace it toward this place. And as you can see, it gives us our 3. So that ends this video. If you found this video helpful, please subscribe. And then let me know at the comment section anything you want me to go over for you, and then I'll gladly do that. So the summary of it all is that if you want to solve for the rational function, the limit of rational functions, especially those with no holes, you first of all try substitution. It is obvious all we did here, the substitution didn't work. But if it works, that becomes your answer. But if it doesn't work, you now simplify the functions and then get out common factors so that you can cancel them out. After which, you get a simple fraction. or polynomial or whatever based on your simplification. You evaluate the limits, and then that is it. Thank you very much for staying, and I hope you do understand. Stay blessed. Bye.